have the slides, alanseiden.com/COMEUR. After the session, I will upload this slide, so it may take an hour or so, and I believe we're trying to record the session as well. So with any luck, we may have a recording, and Torburn will let you know about that. It's our third talk together. Our first one was strategic modernization, which showed what can be done. Some graphical interfaces and mobile interfaces using PHP on the I and communicating with RPG through the toolkit. And we had a talk on the toolkit, and this one's all about speed and performance. And next time, I understand Steve will be on. That sounds great. I'd like to listen to that myself. Now, why does performance matter? Is it just someone says the site is slow and you say, get used to it? No, because speed equals money. Google tried an experiment where they increased the number of search results on their page. You know that traditionally they've had 10, although now they're adding a lot of advertisements, but it was always 10. But Google found that when they increased the page size to 30 results, their traffic and revenue dropped. And they thought that by adding more results it would help people save time and give a better experience, but actually that extra time it took to serve the longer page caused dissatisfaction. Google was always made a priority of speed and simplicity, and it hurt their business to make it more complicated and slower. Remember, they even had a big debate among themselves about whether to include an extra privacy notice on their page and that kind of thing. So that was important to them. In addition, Google again, but in the other direction, when they index sites and rank sites for relevance, Google now takes into account speed of a website. So if two websites have the same speed, so say I'm alanseiden.com, but say there was another PHP person who was doing what I did and had similar content, then Google would rank the faster site as the more appealing site and rank it higher. I guess that makes sense. That's part of the quality of the site is the speed, and that's how Google sees it. And in general, I assume it saves the money if sites go faster because they're reading sites all the time. So it's getting more important from that way. In addition, that people will choose a faster site. Well, I know when I go around, if I find a site that comes up slowly, I think they don't really know what they're doing. That's my first impression. They don't really know what they're doing. A fast site is one of the factors that gives me confidence in it. So I would suggest paying some attention to speed. You don't want users to forget what they're doing. If they're making a purchase on an e-commerce site, you'd like them to flow through and not be distracted and not say, oh, this is too slow, I'm going to check my email now. You want them to continue with their train of thought and go through, and they'll be confident in what you're doing, and they'll give you the benefit of the doubt. So that's about speed. The first thing is, these are 10 basic categories. The first one is to measure it. Measure what the speed problem might be. I've often found that if a site is slow, people will jump to conclusions, sort of just debating it. Oh, maybe it's the database. Yeah, DB2. Oh, this is IBM. You know, the IFS is not that fast at IBM. People may say that, and sure, I know that, but it's probably not the problem, especially with modern hardware. There's usually something that's relatively easy to find, I think. Either a query needs better indexing, or there's something wrong. And anyway, main thing is to measure it. Don't assume. Always measure it and find out. And then it'll be, I find it's not difficult once you measure what the problem is. So in PHP, and this is normal, free, open source PHP, there's something you can do which is very basic. And then I'll show you some ways that come with the more professional versions of Zen Server. They're not free, but first a tip on the normal free version of PHP. There's a function called microtime, and I've highlighted it here in bold. It tells you what the current time is in seconds. So what I would do is I would just add a statement where I measure the start of some process and then the end. So I'll say start. You're making an array with an element called start, and then an element called end, and then subtract end minus start, find the total duration. And if the duration in this case is more than half a second, let's write something to a log, to the PHP log. And then we'll find out what function it was that took the time. This is very basic, a little bit crude, but it really works. So just find out. Maybe it's a query, maybe it's a program call, maybe it's some kind of loop, and you'll be surprised what it might be. So the way to get PHP on the eye, if you don't have it, is to download Zen Framework. Version 8 is the current version, and the basic version is free. When you read on the internet, you may not see many references to the basic free version, but that's because it only exists on IBM I as free. So we get a privilege due to Zen's relationship with IBM. You can also get professional enterprise licenses, which give you support, extra support that is, and more features. And I'll show you some of the features you get. And I'm not trying to sell any of these. I'm independent, but I'll just let you know what it is because I think they're very good. Especially, there's a new feature called Z-Ray, which is very good for performance. But basically, this Zen Monitor and Code Trace, which show you exactly what's happening in the application without having to add any extra debugging. So in this case, there's a picture. A client of mine had a performance problem. It turns out they had a loop. They had a loop. Instead of running a procedure one time, it was running it 1,000 times. And that was shown by the code trace that was shown in Zen Server. You can add various rules to monitor when a query is slow or high memory is used, that kind of thing. And even click a checkbox to show what's the most time-consuming path in the application. In this case, you can see there's a call to a COBOL program that's slow or relatively slow for some reason. It's great if you don't know where the problem is, especially if you're using a large application. It pinpoints it so you can dig deeper. So that's code trace and monitoring. And there's another new feature called Z-Ray in Zen Server, which shows you right in the browser, right at the bottom of the browser, what's happening, if there are any queries, how long each query took to run, which is great because it's hard to keep track of everything that happens in an application. This shows you very easily. I'm finding it's very helpful to diagnose and measure performance. So that's in the professional and enterprise editions of Zen Server. That's good enough that I'd wanted you to show that to you. And by the way, if anyone has any questions, there's a question and answer feature or window on the control panel of GoToWebinar. So I'd like you to please type in your questions, and at the end we'll go over those questions. Torbjörn will ask me, and we'll have time to talk about them. Another tip which really always helps, I suggest you always do this, is I'm calling it compress it. Compress the data. And this isn't even specifically for PHP, but it works anywhere with the Apache web server, is to compress data. You know that if you have a large file and you need to email it to somebody or send it, you might zip it first, right? You'll make it into a zip file and make the file smaller. The same is true of web servers, that it can shrink, compress any text-based file and make it smaller. And because you're sending these files through the internet, if you can make the file smaller, it's good. So it's fewer bytes, and maybe you can even fit into a smaller block as it gets sent. And the features called gzip or deflate, mod deflate, they're about the same. That's true of HTML, which PHP creates, JavaScript, style sheets, anything like that. Netflix used it, and they saved a lot of money and got a large performance improvement. And it also saves money in infrastructure to have less data to have to send, and it comes out the same. And I tried that myself with a test. I used the default old SQL example that shipped with Zen Server. It's at a new URL now, but same test. And if you look at the bottom, without using compression, the page was 31 kilobytes, and with compression it was only 4.4 kilobytes. That's a huge improvement, and it was faster too. It was half the time. It's surprising, but it really works, and it's easy to do. In your Apache configuration, which is httpd.conf, you add this IBM provided load module statement, deflate module, and then add output filter by type directive, which states what type of content would you like to compress. And I said I'd like PHP, JSON, style sheets, JavaScript, even and HTML, all that text-based content to be compressed. That's all it takes, and then restart the web server, and you will notice a speed improvement. And if you do nothing else, I would suggest doing this because I've never seen it cause a problem, yet it will bring you a speed improvement. Even if you're not using PHP, if you're using some other technology, even I suggest you do this, even a static website. And I have a tutorial on my blog, and here's some more reference material. That's called Deflate. And I hope some of you will just go right after this webinar, go to your websites and turn it on. You'll be impressed, I think, with this. And let me know if you get some improvement from it, or I hope you let me know. I'd like to keep track of that. Now, keep it alive. Keep it alive. This is another feature of Apache, which I find will help. Some of you may be familiar with other types of keeping alive, persistent connections and connection pools and that kind of thing. In this case, this is to keep alive so that when the browser contacts the web server and to download, say, an image or a style sheet, the next time it comes to download something else, it won't have to restart the connection. Because normally there's a handshake where there's some communication that has to happen every time for every file that's downloaded. And a web page could have many, many files. A single web page can have many files. And this is a way of keeping a connection open for a certain number of seconds. And with secure sockets, SSL, it's even longer normally to have that handshake. So this will improve the speed. This is not turned on by default, but what you should do, I suggest, is go into your Apache configuration, httpd.conf, and turn keep alive on, as it shows here in the second bullet point, and then turn keep alive timeout, say 15 seconds. What that does is, for every file that gets downloaded, it'll say, I'll keep this connection alive for 15 seconds so that a web page can load faster. I find it to be pretty good. Don't make it longer than that. Even 5 seconds is good. That's keep alive. Maybe for a really busy website, you wouldn't want to keep a connection alive for an individual, but for a website with normal traffic, keep alive can help. And this shows you here in a diagram. I used the tool called Firebug. And you can see the lower left, it says connection closed. That means the connection closed immediately after downloading the file. And in this case, it took actually a few seconds to connect again. If you turn on keep alive, then you'll see that it says connection keep alive, and the connection time is 0. It instantly reconnects, so that saves time. That's called keep alive. And again, it's not PHP specific, but sometimes performance problems aren't even related to the back-end technology, such as PHP. It could be from the front end, or the web server configuration, or something in the browser. So you should rule these situations out first. Rule out the deflate, the compression, and the keep alive. Rule that out, and then see how your application gets faster. Persist it. So this goes back to the back end and DB2. So when you're using PHP to connect to DB2 database, it can be faster, a lot faster, to use a connection pool, persistent connection. That means that your PHP job will connect to a particular DB2 job and will stay connected, and that DB2 job will already be allocated. So for instance, the library list will be set. It'll be initialized for you and for your user profile. It doesn't mean you can go back from request to request, but within a single request, you can access your queue temp and so on. And then the next request, you'll get to the same job. It's a lot faster, so it'll go really 0 connection time. Sometimes people think a query is too slow, but actually it's the connection time if they're connecting, especially if you connect multiple times within a request. And the way to do that is, instead of using the normal DB2 connect function, use DB2 P connect. P is for persistent. It's much faster. And not only is the connection faster, but the SQL statements that might exist can stay in memory. And maybe even temporary indexes can stay in memory. Normally, PHP is stateless and everything is regenerated every time, but this gives you an opportunity to reuse some of the work that the IBM I does. So if you use DB2 pconnect, you'll find a large, appreciable, significant speed improvement. And the way it works is when you give it the database name, which could be star local, username and password, the next time you connect with those from the same job, it'll connect to the same DB2 job. It's highly effective for performance. I recommend you use it if performance is important to you. Another tip, and again, if you have any questions, please enter any questions in the question and answer window, and we'll get to it at the end. And there are many more tips. When I'm at ZendCon, I can do a full day on performance. There's so much to say. There's a lot to say. But I find these are the 10 most important areas to look at with performance. Caching. I'm sure some of you have done some caching. The operating system already does some caching for us by keeping objects in memory as much as possible. But we can control that ourselves too. And within Zen, Zen Server gives us a couple of kinds of caches. I'll talk about two of them. Actually, both of these, I believe both are free now in the newer edition of Zen Server. It used to be that only Zen Data Cache was free. I believe the Page Cache is free too. I could be wrong about that. Zen Data Cache definitely is included at no extra charge. And it allows us to have any kind of data saved, any kind of data. So for instance, you might take the results of a query that could be in the form of an array, let's say. And you can save that data, you give it a key, some kind of key, and save it, and you can bring it up anytime, any other time in the future. And other users can bring that data up too. It's very effective. I've even saved the contents of an HTML page that way, that's slow to be created. I saved the HTML in Zen Data Cache and brought it back up later. I've seen with a client of mine that they had a stored procedure that it was really slow. It took a minute to run. This is on older hardware. It was a couple of years ago. But it took a minute to run. I remember 101 seconds actually. And by storing that data in data cache and then coming back later, it was almost instant to retrieve it. And it was data that didn't change very often. Maybe it changed once an hour or so. So if you think about how often your data changes, you may find that some doesn't change very frequently, and you can cache it. The other kind is Zen Page Cache, which lets you cache a whole page or JSON content or something that doesn't change. You could actually cache the HTML. Let's go through these one at a time. So Zen Data Cache, if any of you have used Memcache, it's very similar to that. You do a cache fetch or a cache store, and fetches, stores it. Here's an example here where in this PHP code, we say if a district number is not found, then we look it up and store it in the cache. Otherwise, we've retrieved it, and we echo it in this case, output it. It's pretty simple. You can store it in memory or disk. If you store it on disk, then the data will persist even after you restart the server. Or memory is faster, but will not last. And you can also set time, how long you want the data to last. You can say, I want this data to last for a day, or for an hour, or for a minute, or a second. It's very effective. Then Zen Page Cache, this may be free in version 8. I'm not quite sure, but what you do is you specify a URL, and then Zen will automatically cache that. So for instance, if you can see in that screenshot, it says rule name, welcome page. That means that home page will be cached. Next time somebody comes in, it will be served without any calculations being needed. And that can be the fastest way because it's not even having to run any code. Works really well. That's Zen Page Cache and Data Cache. Those of you who use the PHP toolkit for IBM I, and I gave a whole lecture about that a few weeks ago. That's a way to call RPG programs, COBOL programs, service programs, reading data areas, and so on. Here's a list of some of what we can do. Work with data queues and spool files and user spaces, commands. It's very effective because RPG is compiled, so if you have RPG or CL, it's very fast to run it. And you can reuse your existing logic, your older logic, or new logic. And if you have RPG programmers who are skilled or COBOL programs, you can continue to develop in those languages and bring your data to the web and bring your logic to the web without having to rewrite it. I think that's great, saves money and time, and it's very efficient. So that's how we use the toolkit. I give this example, for instance, we took 4 green screens and turned it into one web page. 4 RPG programs are being called. The RPG programs were changed to have parameters in and out. And 4 programs, like header, detail, content, and something else were called, and then the data shown on a single web page transparently. And this was done, the speed was very good with this program. But I'd like to give you some tips to make sure that your speed is fast with the toolkit. One is to try to avoid using the disconnect function. Some of the sample code that comes with Zen Server shows disconnect that ends a job at the end. It opens up a private job private toolkit job and then ends it. So if you need to use the private job to come back to again and again, there's a better way. Instead of using disconnect, you can set up a timeout so that the job will end. In this case, if you look at the bottom, it says idle timeout 3600. That means the job will end in an hour of inactivity. And that's better than disconnecting and constantly having to reconnect. That's too slow. So don't do that. That's one way. Another easy way is to connect with stateless mode. You can see the last PHP statement here. It says stateless is true. And what that does is it doesn't need to create a new toolkit job. You'll just run through an existing database job. And if you use a persistent connection, so if you specify true for this get instance, the fifth parameter, true. Remember I said persistent database connections are fast. If you say persistent is true and stateless is true, then the toolkit will ride on top of an existing DB2 connection. No new jobs will have to be created. No new jobs. It will use existing jobs and it will connect very quickly. You will not have to disconnect or reconnect. No new. Your operators will not be upset with you because you will not be creating any new jobs. So it's nice. So that's one tip for the toolkit. As I said, don't use disconnect. But there are some other tips also. Don't allow any inquiry messages to arise, such as message waits, data decimal errors, or level checks. Don't let them occur because it's not as like with the green screens where the message would pop up and the user could answer it or call the operator. This is different. Now we have the web in between, and the user will not be able to see that inquiry message or answer it. All they know is their web page will hang until the message is answered. That's bad. Don't let that happen. What I suggest is, I talked about this in more detail in my toolkit talk, what's better is to wrap the RPG or COBOL program in a CL program and monitor for any messages, and then pass back a flag to PHP to tell it success or failure. Or use system reply list, or use some other way to ensure no inquiry messages arise. It's very important. That may not seem like a performance issue, it's more like a quality issue, but to your users it will seem like performance. They'll say this is slow and actually it hung. In addition, don't use any commands or programs that will generate an error, like add library list can generate an already exists error. It's just a warning, but it'll slow down the program because it'll try to return error messages, so avoid that. And in the future we may do something about that, but for now try to avoid that. What you should do is probably use a stateless connection, or at least don't disconnect. In addition, there's a parameter called plug size, which represents the amount of data we expect to get back. Try to make it as small as you can. 4K. 4 kilobytes, for instance, is the smallest you can do. Use a persistent database connection. And if you can, try to group multiple commands or program calls in a single CL program. It reduces the number of calls you have to do, and it will speed it up. CL is great, and I don't know about in Europe, but in the United States, people are forgetting about how to write CL programs. The younger people don't know about CL. But it's very powerful to combine more than one program call or command in a CL program. Not only can you monitor messages and control it that way, but you can also reduce the number of calls to make. And in particular, with the toolkit, these retrieve commands, like retrieve user profile, can be slow. But if you wrap it in a CL program, it'll be fast. So wrap everything you can in a CL program, and you'll get better speed. Okay, that's the toolkit. Any questions? Even if it's not directly related to my topic, I invite you to ask questions. Send them on the question and answer link or window. Now, index it. I'll just go, actually I should just let you go back to this DB2 workshop with Mike Kane and you'll learn more about this. I'll just say a couple of things because not everybody's that savvy about DB2 and IBM I. Some people from the PHP world aren't aware of what's available. And there's some really nice tools in DB2. I'll only just mention a couple of them quickly, but I know you have a lot of other resources to find out about it. There's a really good book from IBM here. It's linked here in a PDF about database performance and query optimization. Just a couple of things. One is the Index Advisor. This is the thick client one in Navigator, but it's also available on the web too, where you could look up and find out for a given table what indexes the system has advised. So if the system thinks this query is too slow, it will advise indexes for it. And this is really amazing. It's happening in the background without our even trying to make it happen. That's part of the value of IBM I. It's taking care of us. We don't always appreciate it or realize it. It's like our parents. They're feeding us and taking care of us, and we don't even notice they're there. Right? And really, it's doing a lot to take care of us in the background. And that's an example. It's the index advisor. Another one is SQL plan cache. For your queries that are running, it captures the query and lets you know who's running them and how long they take. And why is this important? Because we may be running complex applications and we may not realize what queries are running, especially if we have developers working with the front end, such as with PHP. Sometimes we have developers who aren't really IBM I developers per se, and we don't realize everything that they're doing, and this is a way to see what's happening on the back end. Or we may be using various tools or frameworks. We'll find out what's really running. One tip I have is when you write DB2, you could put a comment on the end. Use 2 dashes and a comment. And then you'll see in the query the comments that came out. You'll find out where it ran from. You could say, for instance, comment, this query is running from getcustomers.php. And then you'll find out when you run in a tool like this, it will show you the comment. That's the plan cache. So then this way you can index your queries appropriately. And there's so many neat ways to do it, from encoded vector indexes, all kinds of new indexes. So in general, I also suggest you learn everything you can about DB2 because it's developing very rapidly and it's great. Reduce it. What does that mean? Reduce it. Well, because a browser uses the request response protocol, a browser is asking for multiple pieces of content. It's not just an HTML page or a PHP request. It's got the HTML, and then it reads the HTML page, and then it sees, oh, I need images, I need style sheets, I need JavaScript. Especially now with Ajax being so popular. So it's going to make many, many, many requests as it goes. Each one is a separate request to the web server, which is amazing that that's the way it is. And it can only do, it's doing 1 file at a time or maybe up to 6 in parallel, but it's all separate requests. So what should we do? We should somehow try to reduce this, and because each request also goes through these separate layers, through a firewall, through the internet, maybe proxy servers. A lot is involved, every request. So what we should do is reduce the number and size of requests. We already talked about one technique, which is to use a deflate to compress the size of the data. And that helps a lot, using the deflate or gzip. But what else can we do? We can also reduce our content in many, many ways, and I suggest to find out, use a tool. There's one called Page Speed Insights that Google provides, rather than have to figure it out by hand. And Page Speed Insights, there's also a Page Speed plugin to Firebug. But if you use this, it'll show you what mistakes you made in your web page. And this is not for PHP only, it's for any web page actually, no matter what you use. It'll show you your mistakes and give you guidance on how to improve and how to learn. It's like having a performance consultant right in your computer. And the link is right at the bottom. So I'll give you an example from when I ran this, and I found a mistake that ordinarily I wouldn't have found. So one of them is, if you have a lot of JavaScript or style sheets, it'll tell you to combine them into fewer of them. Because we're programmers, we like to be modular. So to be modular, we may split up our JavaScript into separate files and style sheets, but for performance, you should combine them into fewer files, so it's fewer to have to retrieve. Or even stick the JavaScript or style sheet in line in your HTML file if it's small enough. Here's a funny one, though. I ran the Page Speed Insights on an iPro developer page, and I found this picture of Mike Pavlak. Some of you may know Mike Pavlak from Zend. Well, one of these pictures was huge. In fact, this first suggestion that the Page Speed Insights gave was that the image was resized in the HTML. Rather than being sized appropriately in the first place, it was a large image served and just sized in the browser. So if it were sized appropriately, it would have saved 3.5 megabytes, 99%. So I can picture what happened, that Mike sent his normal large headshot, and the people, the production people, did not resize it to a small size. They just served the page and set a height and width in the web page. So it looked smaller to the end user, but the large image was being served. And this is even more important for mobile sites because of cell phone speed, and that the large image is still being served and downloaded. So this is something that's not visible to the naked eye, but if you use a tool such as this page speed insights, it would tell you exactly what your mistake is. And you can see that there are others also. There are 4 more on this one page that says that the image should be set to a smaller size. So I suggest doing that. It's really helpful. Another tip, upgrade it. What do you think that means? In your mind, what do you think I mean? Certainly upgrading your IBM I will help, your power systems machine. If those of you who've upgraded recently will know how much faster these Power 8s, how much faster the systems have gone. In fact, a customer called me a couple of months ago saying, we have a performance problem. We're using this DB2 storage engine through MySQL. We think we're doing something wrong. We were referred to you by our business partner. We need help. We think we're too slow. I asked them what kind of hardware they were on. They told me it was older hardware. They were planning to upgrade their hardware in a couple of weeks to get a Power 8 system. And for the Power 8 system to be installed by a very good, one of the top business partners who really understands IBM I. I said, upgrade first and then let me know how it went. I told them I bet their problem would be solved by the hardware upgrade. And they did, and they said, yeah, our problem's gone. And later I talked to the business partner at a user group meeting where I was speaking. He said, how did it go? I said, I told them, wait till they upgrade with you. It'll solve their problem. He said, oh, no, that's why I wanted them to meet you before you upgraded so that you would figure out you could find their problem and solve it before they upgraded, because after they upgraded, it'd be fast. I said, well, I didn't need to solve their problem. The hardware handled it. That's how I felt. So I feel people could probably save consulting money if they would just upgrade their hardware. But actually, there's other ways to upgrade too. PHP itself is constantly coming out with new releases. And at the ZenCon conference in 2013, somebody sent me an example for my workshop. And it was a routine that was very heavy in calculation. It was for the pipe industry. It was doing a calculation on how to optimize their resources. And because the routine used many arrays and objects along the way for their calculations, I decided that the newer version of PHP might help. So I asked everybody in the room to try to figure out how they could make this faster, and it was a trick question. The answer was upgrade to PHP 5.4, and it ran 50% faster. So upgrade your operating system, your hardware, and your PHP and other tools. And there's a new version of PHP coming out maybe at the end of the year. It's 7, which is maybe very much faster, much faster. So keep upgrading and get the benefits of what progress. If any of you have some upgrade stories that are dramatic that might be interesting, I suggest you share them and would hope you'd share them on the question and answer or the chat. I'd like to hear about it. So this helped this person a lot, and for more complex code, it really will help. How about another one? The Optimizer, Optimizer Plus. So PHP comes with an opcode cache. They've actually changed the name. Now it's opcache. We often hear people say, PHP, it's interpreted. That's going to make PHP slow. But actually, most people run PHP with an opcode cache or optimizer. And what the optimizer does is, as PHP runs, it's interpreted and compiled in memory. So the optimizer, which is included within server, the optimizer takes the compiled code and keeps it in memory so that in the future that code will run as if it were more or less compiled. I wouldn't say it's as fast as RPG, but it's pretty fast. It works well. So Optimizer Plus gives us a big speed improvement. And there are other things we can do to make the Optimizer Plus even faster that are configurable. For instance, the amount of memory to allocate to Optimizer Plus. By default, I believe it's 64 megabytes. You can make that larger. The number of scripts to hold in memory, which I believe is 2,000 by default. And then there's a timestamp checker. because we're always running a balance. And this is a balance in computing in general between being dynamic and being fast. So compiled code is not dynamic because it's frozen in time, but it's fast, right? In PHP with the Optimizer Plus, we try to strike a balance between the two, of dynamic and fast. The PHP is highly dynamic. It doesn't have to be compiled. A developer can change their code and save and immediately run their updated code without having to recompile. That's dynamic. But that means it's also being interpreted all the time. So that's why Optimizer Plus holds the opcode cache in memory. And by default, every 2 seconds, the opcode cache will check for a new release or a new version of your code every 2 seconds. And it checks for an updated timestamp every 2 seconds. But if you're running in production and you know that you're not changing your code very frequently, you can increase that length of time or even turn off the timestamp check entirely. So by default it's 2, but I've seen it made a big improvement to make that larger. And here's how to do it. And in the Zen Server graphical interface, you see that the last radio button on the bottom, it says validate timestamps, and by default that's turned on. But in this example, I turned it off. So if you're running in production and you're not changing your PHP code, you could turn timestamp checking off. And the fourth from the bottom is the revalidation frequency. So if timestamp checking is on, you can increase that number from 2 to something higher. And then the Zen server will not be checking all the time for newer code. It'll be faster. The only problem is if your developers are still developing in that partition, they say, hey, I updated my PHP code, nothing changed. You say, I know, that's because I turned timestamp checking off. Really, it's ideal if you could have 2 separate partitions, one for development, one for production, because they might have different characteristics. The development one might have a low timestamp frequency checking fast, and the other one might have timestamp checking totally off. It's up to you. But anyway, I've done this with my clients, and it's been pretty effective. So are there any questions? Now's a good time to ask any questions, or I can just riff and talk more. I didn't want to overwhelm you with too many ideas. I actually combined a number of different ideas. One of them is to optimize the front end. So not only PHP, it's PHP, but the front end too. So that means turn on your mod deflate gzip. You want to compress your content that you're serving from your website, even if it's not PHP, whatever it is, compress it. Turn on Keep Alive to be able to maintain persistent connections with your application. That's also very helpful. Use a tool such as Google's page speed, which will tell you what you're doing wrong, what it sees you may be doing wrong, or mistakes you're making, and ways you can improve the speed of your website overall, whether it's PHP or not, that will work. That's the front end. I find people aren't always aware of that because they're so focused on the server side of the back end. But the front end is where a lot of the speed has to happen. I mentioned that if you use DB2, you should use DB2P Connect, persistent connections. Make sure you use persistent connections. You should also, if you use the toolkit to call your RPG COBOL programs, I recommend you wrap up multiple calls in a CL program. That'll save you a lot of time, and it's very efficient to use CL. Make sure you monitor any messages so that you don't get messages waiting with your toolkit calls. You should, and the toolkit really is great. Instead of rewriting all your business logic in PHP, write an RPG and COBOL on call. It's very efficient to work that way. In addition, upgrade your operating system, your server, and PHP itself. Later versions of PHP improve their performance. Measure any performance issues that come up, so use the micro time. Micro time true will tell you the number of seconds you can find out in your code. Also, if you have more premium editions of Zen Server, you can use code trace and monitoring and Z-Ray. And you can also you can cache your data with Zen Data Cache and Zen Page Cache. And finally, with the Optimizer Plus, remember that you can turn that timestamp down to be able to cache your opcode information for a longer period of time. There's so much more. When I do my full-day workshop, I talk about the performance tools from IBM, such as Performance Data Investigator and Job Watcher, where you could look at an operating system level. You could see what's happening at the IBM level. And if we had more time today, I'll go into that. That's what I do in my longer workshops, talk about that as well. I'll just throw out a couple of other ideas. If those of you using PHP, do you use sessions, PHP sessions, in order to keep data in the background? Well, if you're using a lot of Ajax, your sessions can conflict. So just don't overdo the Ajax. And you may even want to use, you may find even that if you have too many Ajax requests that your PHP sessions may even conflict and lock. So watch for that. I can give you a tip on that if you need a tip. There's a way to solve that. So I don't want to say any more ideas. I think now you should ask me some questions. And then I want to allow Torbjorn to go back to his DP2 workshop. Questions. I find performance is a topic where if you're not already using PHP and you're not having an issue, then it's good just to keep these things in mind. And note there are many, many ways to make your application faster. So I'd just like to turn it over to Torbjorn now, see if he has anything to say.
No, there are no questions. Zion Cohen just raised his hand, but I don't know if he wants to ask any question. I'll try to chat with him. Should I unmute them perhaps? It's not more people than this.
Okay.
We'll unmute everybody and see if there are questions. We'll try this, and I mute them again. Any questions for you guys listening in?
This is Zion. I don't know if you hear me.
Yes, we hear you.
My question actually was regarding upgrading just the PHP within the Zen. How complex is the process of just upgrading the PHP?
Alan, do you hear us? Oh, Alan wasn't. Okay, sorry, Alan, come again. You were muted.
Yeah, I got muted. Zion, yes, thank you for the question. The upgrade process is pretty difficult, but it's gotten easier now, depending how you look at it. Zion, what version of do you have Zen Server installed right now?
Yeah, we have Zen Server. We have version 7. We actually come across the problem about a year ago on a matter of security, and the requirement was just to upgrade the PHP, and it seemed like a very complex task. So we went into upgrading the Zen server.
Yes. Oh, yes. Upgrading Zen Server is the way to upgrade PHP. You can't just upgrade PHP by itself. You upgrade Zen Server, and that upgrades PHP at the same time. It's gotten easier recently because you may have noticed that the Zen Server installs into the same library for every release recently, so that you can install the UTF to upgrade from 7 to 8 as you go. So that's how it's done.
Okay, thank you.
Okay.
All right, you're welcome, Zion. Thank you for the question.
Okay. Otherwise, I think it's time to end this webinar, and we say thank you very much, Alan, for all 3 sessions. And yes, you have the link in the presentation, also information about your newsletter. Okay,
yes,
thank you.
alanseiden.com/tips. Thank you so much, Torbjorn. This was great doing this, being here with the first series of Common Europe webinars. It was a privilege. I hope to meet many of you in our life here in IBMI.
And see you in Anaheim at the Common Conference, Alan.
Yes.
Take care.
See you there.
Bye-bye.
Thank you.